Hey everyone, I'm Abhinav, and today we are going to present our DIY group project, which is a multi-implementation line follower or an MILF. So, first of all, we would like to thank Professor Archana Arbind for her guidance and support, as well as providing us the opportunity to work on this project. And from this project, we've developed a lot of skills necessary for applying our theoretical concepts to practical scenarios. So, thank you very much, ma'am. And as you can see, we are group 3 of subgroup 3, and our members are Evin Roy, Dev Kumar Gupta, Vivek Mirani, and myself, Abhinav Vijuplai. Now, what are the applications of such a line following robot in real life? When you think of such a robot, it can follow a fixed path that we have set on the ground. So, one such application could be in public transport, where we can paint these lines on the road and we can have certain set of buses follow these paths to take passengers in circuits. So these buses will follow these lines, stop at certain preset points, and they will follow a set of pre-programmed instructions. At this junction, go left, at the next, go right, and they can pick up passengers automatically without human interference. Another application is in restaurants, where we can have these line following robots operate as robotic waiters, and they will take the food from the kitchens to the customers at the table. This can increase business by attracting customers as well as provide some entertainment value. Now, another application of robots is in places where humans are finding it difficult or there is some danger to human health. And in such cases, one application is radioactive waste disposal or any kind of dangerous material disposal, where we can set this line and tell the vehicle to carry out the task without danger to human beings. Another application is when tasks are repetitive or boring and human efficiency will be low because humans will of course get tired. And one such application is security patrols. So we can have these lines set around neighborhoods and offices, and we can have these robots patrolling it in a fixed path on the lookout for unidentified individuals. Now, let's look at the schematic of our project. As you can see, this is a 3D design model which will be explored further later in the presentation. But right now we have just the top view and the bottom view of our model. And each of these parts that I have labeled here will be explained later on. Let's see, briefly, we have the wheels, a breadboard, the motor driver, and the chassis. On the left side, when we see from the top, we can also see the Arduino Uno and the batteries. Whereas on the right side, we can see there are 4 DC motors on the underside, as well as 2 caster wheels and 2 IR sensors. And in the middle, there's a small metal piece, a chassis connector, which holds everything, which holds the chassis together. Now, as you can see, this is our project timeline, which we have been working on for the past 4 weeks. In the week 1, we had covered the selection of the topic and research of the concept which we will be working on, as well as analyzing the material availability. Will this project fit within our budget? And such things. And also we worked on some basic circuit design in Tinkercad. Then in the next week, we ordered the materials we needed, as well as prepared the code for the line following mechanism and the 3D CAD model. And week 3, we have done the assembly of the prototype at my house and the coding for turning at the junctions, as well as a debugging of program to make sure there aren't any errors in it. And in week 4, last week, we have been doing error analysis by trial and error, repetitively trying the robot to find the proper values, as well as the final touches on the model and the presentation preparation. And as you can see, these are the materials we have used in our presentation. All of these have been covered so far. On the next page, we have some more. Here we have some extra materials which are not present in the schematic, like wires, insulating tape resistors. These are things that we had to buy spontaneously as we were building the model. And here we have the relevant links and simulations for our project. The different parts will be explained briefly. So we have the CAD design, which will show the 3D view of our model, steering mechanism, which will explain how our robot is working mechanically, and the circuit and simulation, which will explain the working of the program. So right now, I'd like to hand it over to Ivan Roy to explain the CAD design of our model.
Morning everyone, I'm Ivan. So this is the 3D model for our multi-implementation line follower robot. Here we can see two chassis for positioning and keeping the other parts, four wheels and for DC motors. We can also see two caster wheels for better movement and for supporting the two chassis from bending. For the electronic part, we can see an Arduino Uno board, a breadboard, three 9-volt batteries, a 293 3D IC motor driver, uh, two HW201 IR sensors, which have been placed between the on a frame between these two chassis. Uh, the two batteries in the slot provide power to the our DC motors to the through the IR through the L293D motor driver, and the battery here provides power to the Arduino Uno board. The IR sensor emits radiation and receives the reflected radiation. It then calculates the intensity of the reflected radiation and distinguishes the color of the path between white and black. This working of the IR sensor plays an important role in our project. Now, the required steering mechanism will be explained by Dave.
Hello everyone, I am Dev Gupta and I will be explaining the steering mechanism of our project. We have a rough diagram of our track and sensors. So as you can see, we have a red box in our cart and as our cart, and we have red spheres which are the sensors of our model. So the concept of a model is when any sensor detects white light, the wheels on its side starts moving, whereas when it detects black light, then the wheels on that side stop moving. So at the beginning of our motion, both the sensors detect white light as it faces the ground. It keeps moving in a straight line. And as the object moves and arrives at a turn, this sensor faces black light, whereas this sensor faces white. So according to our logic, this point stops moving, whereas this point keeps moving. Since Tinkercad does not allow us to pivot about any other point except the center, so I will not be able to show the turn with exact precision, but but it will look somewhat like this. So when the turn is completed, both the sensor detects white light and it start moving in a straight line. And if we continue, the object reaches the junction or the intersection in which both the sensor detects black light. Since its major application are in the sector where it will have its predefined path, so our code is fed in such a way that at this junction, it has to move right or left according to the destination it has to reach. Let's assuming it to be moving left, then it will use the logic of this curved path here to take a turn to take a left turn. Then it will use the then it will use the code for a single normal line following to move further. So this was steering mechanism, and I would request Vivek Mirani to explain the circuit.
I'm Vivek Mirani, and this is the Tinkercad circuit which we'll use for the model. So the basic components are the Arduino, the motor driver, the four DC motors, and here we have used a photodiode because the IR sensors in Tinkercad do not allow us to work exactly how our model will work. These are the batteries. Now I'll start the simulation. Initially, both the photodiodes will detect white light. And as you see here, the left and the right motors, they are rotating in opposite directions when viewed from the center of the axle, and thus the bot moves forward. Now, in the case when the right sensor, it detects black light, so the line is towards the right and the bot will need to rotate towards the right. So the right motors would stop rotating while the left ones would continue rotating in the same direction and the bot would make a turn, as you can see here. Similarly, for the left thing, it has a similar logic. Now we have fed an array here, which will decide how our bot makes turns. So this was the initial condition. Now this is the first turn which the bot will make, which is towards the left. As you can see here right now, when I make both black, then the left motors would stop rotating while the right ones would continue rotating. So this is the thing. And then both of them would detect white again, and the bot would start moving towards, like, it would follow a straight path. So I will show you the code which we have used. So uh, first of all, the complexity of the code didn't allow us to use the blocks mechanism, and we had to learn C++ to code our bot. So this count, it keeps track of the number of intersections which has been encountered till now. PD left and PD right store values which are fed from the IR sensor inputs. And this turns array, it is the array which decides what turn our bot will make whenever it encounters an intersection. So here the different pins on the Arduino have been set to inputs and outputs according to their uses. Now the 3 and 5 here, they are the enable pins which are always set to high. Then when both left and right sensors detect white light, our bot has been programmed to move straight. Similarly, when the right sensor detects black, while the left sensor is still detecting white, it will rotate towards the right. Similarly, for the left part, now when the sensors both the sensors detect black light, our bot has encountered an intersection, and it will follow this logic of an L for turning towards the left, R for turning towards the right, S it will stop for 5 seconds, and it serves the purpose of carrying passengers at a stop. And there is also a 0 at the end, which is the final stop our bot will make. Now let's have a look at our running model.
Okay, so I hope you understood how a robot is working from looking at the video. So now let's look at the work distribution. So Dev Gupta was in charge of video editing, presentation preparation, and the component research. So this whole presentation was done by him, like the what we have written and the templates, etc. And the video you just saw, as well as the component research, as in the parts we will need and how much their price will be, etc. Vivek was in charge of working on the Tinkercad circuit and the coding part of it, as well as the application analysis. That is, figuring out what kind of applications we can use this robot for, what will be the limitations of those, and what extra modifications we'll have to do to work on that. Ivan was in charge of making the CAD 3D model, the simulation you saw earlier, as well as the final assembly of the model, the hardware prototype, along with the purchasing of the parts. While myself, Abhinav, was working on the coding and the Tinkercad circuit, as well as the final assembly, which was carried out at my house. So as you can see, all four of us have contributed a significant effort to this project. So now let's look at some of the challenges we have faced while working on this. One of the main issues was the absence of campus, like because we are online, all four of us are in different places. So it was somewhat hard to coordinate, and some of us felt like we could felt frustrated because we could not work together to solve these problems. So it was somewhat frustrating, but we were able to manage by conducting these online meetings and like putting different cameras with multiple positions and stuff. Then there were a lot of connection issues faced in the hardware model. When we do the wiring kept coming loose. So each time we run the test, the wiring would come loose because it's a moving model and there will be some hustle and bustle which will knock some connections loose. So we had to rewire it several times. Another one is faulty parts. When we ordered some of the parts, some of them weren't working properly, some of them were burned out, and we also inadvertently ruined some of them because we were not experienced with this. So we had to spend more time getting new parts and learning to work with what we had. And the final challenge was one more of logic and uh, thinking related, like navigating these intersections. The mechanism for turning at intersections is still not exactly working as we would like it to, because we've made it as best as we can using the resources we have right now, but it's not working under all conditions under a general turn. The bot is able to identify an intersection, but it can't always take the turn. It can only do in certain conditions. So these are the challenges we have faced, and we were able to somewhat overcome these by using some combination of hard work and uh, thinking. Then these are the softwares we have used for doing this project. We have Microsoft Teams were used to conduct these meetings, and Google Docs and Google Slides was used for collaborating on ideas and making notes, and Slides was used for preparing this presentation. Whereas Tinkercad was used for simulating the circuit and making the 3D CAD model. Windows Paint was used for sharing our ideas in the meetings, and Adobe Photoshop and iMovie were used for the video making and the picture design things. So as you can see, each of these are hyperlinked, so you can click on these to go to the installation website. And this is the bibliography, like the links we have used in our project, the images, the component list for the parts, the reference video from on YouTube, which we used to learn from, the website for purchasing the parts, and this template for this presentation that we got from the internet. Thank you so much. That was our presentation. I hope you liked it. Thank you.